Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shakila binti Ikmalisha. The title of my research paper is a review on conventional technique for producing porous scaffold in bone tissue engineering. Basically, tissue engineering is a concerned technology that creates implantable material as a bone substitute for critical defects that cannot be healed by its own. Tissue engineering can be explained as restoration, enhancement, and maintenance of destruction tissue that causes by illness, infection, or injury. An artificial extracellular matrix is essential design in tissue engineering that manage cellular behavior that includes growth, migration, differentiation, and survival. Scaffold is the temporary helper in cell regeneration for the purpose of healing process and act as new tissue. The development of scaffold should follow specific chemical or physical requirements and specific mechanical properties to accomplish better achievement of cell diffusion and three-dimensional tissue formation. The scaffold developed for tissue engineering must be highly porous with huge interconnected pores to encourage mass transport and nutrient transport into the cell. There are several methods or techniques had been used to fabricate porous three-dimensional scaffolds structure of polymer composite. The techniques of porous polymer ceramic composite can be classified into two, which are solid free form technique and conventional technique. In this review paper, I would like to focus more on conventional technique. The objective of this review paper is to study the conventional technique such as gas forming, freeze drying, electrospinning, and sol gel for producing porous scaffold. The designation of the scaffold have many characteristics such as good mechanical properties, easy to fabricate, adequate biocompatibility and biodegradability with controllable degradation kinetic. Other than that, scaffold can be projected as a 3D template that comply for proliferation, cell addition, ECM formation, differentiation, and environmental friendly. Ideal bone scaffold should have similar composition and structure to the natural bone extracellular matrix. The scaffold developed for tissue engineering must be highly porous with huge interconnected to encourage mass transport and nutrient transport into the cell. Porous structure of polymeric scaffold could be controlled by varying the processing or formulation parameters such as polymer solution concentration, solvent, and water phase concentration, and control the temperature. As you can see on the figure, it is a bone defect that may be caused by illness, injuries. It will imply with the 3D scaffold use a lot of ceramic compositions such as hydroxyapatite, caprolactone, gelatin. The ceramic composite will implant into the bone defect and undergo the osteoconduction and osteoinduction process to replace the defect and become the healthy bone. Okay, for the conventional technique, it is a simpler process and low cost compared to solid free form technique. There are various types of conventional techniques such as gas forming, electrospinning, freeze drying, and soldier process. Gas forming is a favorable technique that enables of highly porous matrix via particular high supercritical carbon dioxide gas. While electrospinning, it is an easy and flexible technique for the development of ultra-thin nonwoven fiber with a diameter ranging from nanometer to microns. Freeze drying is a method that used to construct highly porous 3D scaffold by dissolving polymer in a solvent at high temperature. The last one, solder process. It is a bioactive glass that embedded in a porous structure that used as a 3D models to stimulate bone growth. Actually, there are others type of conventional technique, such as particulate leaching, casting solvent. Okay, for solid free form technique, I will explain a little bit about solid free form technique to compare with the conventional technique. Solid free form technique will focus on how scaffolds have performed clinically and made it feasible for tissue engineers to construct and fabricate a whole range of new types of scaffolds. The special part of solid free-form technique, it is enabled to create a physical objects directly from computer generated models. So if you want to, let's say if you want this model, we can just generate this model from the computer directly to become what we want. Other than that, solid freeform fabrication can enhance the tissue engineering by adjusting scaffolds parameters such as porosity, pore distribution, pore size, and incorporating an artificial vascular system. The limitation of conventional technique can include manual intervention. It is a manual-based process with multi-stage processing with constraint of time and workers. And the second one is use of porogen. The particle of porogen will remain within the scaffold and cause the inconsistent pore densities and morphologies. The third one, the utilize of toxic organic solvent that cause the adverse effect on the adherent cells and incorporated biological active agents. And the last one is inconsistent and inflexible processing procedure cause the limitation of conventional technique. The conclusion can be made from this review. There are few types of methods can be applied to fabricate the scaffolds to obtain better porosity and mechanical properties. Conventional technique are the suitable technique to be used in scaffold fabrication with extended range of pore size. That's all from me. Thank you.